Here is a little example of how to build an authentication signature and the hypothesis, just to illustrate the previous presentation. Let's say that Bob wants to authenticate to Alice and calculate its authentication signature from Bob to Alice. So let's compare the values of n to know which one is the lower and the greater. Actually here, NA is equal to 143 and NB is equal to 209. So here NA is lower than NB. So the step one will be calculated by Bob. It's SB to the power of EA modulo NA, which is 103 to the power of 17 modulo 143, which will give the value 38. Then step 2, calculate the first one and then use dB and NB. So it's SB to the power of EA modulo NA to the power of dB modulo NB, which will give us here 38 to the power of 143 modulo 209, and the result is 114. So that's the value of the signature used by Bob to authenticate to Alice, and this value will be sent to Alice. So now that we've seen the process of creating this authentication signature, from this example, I will show you how Alice will check that Bob is really the sender and has produced this authentication signature. So actually, what Bob does is send this value as from B to A, which is equal to 114. So what happens next actually is that Alice, in order to check that Bob is the sender, will do the reverse steps in the reverse order, of course, and she should find the signature of Bob, which is 103. So from the authentication signature, Alice should find the original signature of Bob here, which is 103. So in order to apply the reverse steps, actually, it's all based on the values of n. So to check an authentication signature, use the greatest value of n first. Okay, so here, so I'll go a little deeper. When Alice checks the authentication signature, just as for creating one, she will use the data that's available to her. So she will use actually the signature she's just received, then her private key, because the signature has been built using her public key, so she will use her private key to decipher it, and the public key of the sender, because also the authentication signature has been ciphered using the private key of Bob, so actually she will use his public key. So here, in order to check use the greatest value of n first. Here, remember that NB is greater than NA. So what she will do is take the authentication signature and use here the key associated to the greatest value of n, which is NB. So that's EB to the power of NB. Then in a second step, take this value and use her private key to decipher it. Okay, and actually, if we do the reverse calculations from the values in the example, actually, we will find that the final result here will be 103, which is equal to the signature of Bob. So that is a way to check that Bob is the person that has produced the signature and so is authenticated.